hot.
Yeah, I know it's very hot, right? Hello, Eric, Ryan. Are you right? Yeah. Okay, so last week we talked about, probably not last week, 2 weeks ago we talked about the linked list, right? We reviewed the linked list, which is the data structure. A node points to next one. It's like a chain, right? A chain is, imagine a chain, one after another. This is very important, right? This concept is very useful, very important in blockchain, right? Sooner or later, I'll teach you the blockchain, okay? Distributed ledger, okay? Distributed ledger, the linked list. So today's task very simple. We are given a linked list, right? A number points to another, okay? And this goes on. Okay? And we're given an array of numbers, 9, 2, something like that. Okay. For simplicity, the numbers in the array are all unique. There are no duplicates in these numbers. This is the linked list, which we are given a head. Okay? And then our task is to remove the elements, remove the nodes here which appear here. Okay, so we want to remove the nodes in the linked list which values appear in the numbers. Simple, right? We have 9 and 2 here. So meaning that these two nodes, if they appear in the linked list, they're to be removed. So we have 2, we have 9. Okay, so the remaining will be 1 points to 8. Simple, right? This question is for primary school or even less, right? We're given a list and we want to remove the numbers.
Definitely not primary school.
No? But do you understand the problem? Right? It's simple, right? We're given a list of numbers, right? And then we want to remove the numbers appear here, 2 and 9. And then we want to make return the head of the linked list. Okay? And we know that all the numbers in here are unique. And also, we're given this.
Did we use this problem before?
Yeah, could be. Yeah, we have talked about like almost 700 days, and I kind of forget, right? Probably we have seen this before, right? So, but it's a good thing, right? If we seen it, before, then this is the good time to review. Okay, so yeah. Okay, so do you remember last sentence I said last lesson? I said, almost all the linked list problems can be converted to an array. So yeah, this is the trivial way to solve it, right? Because linked list we can convert to array. So we convert to array, and then we remove the numbers from the array, and then we convert it back to linked list. Problem solved. Almost every linked list problem can be solved that way. But this is kind of like cheating, am I right? Because you're not actually solving it using the linked list. If we convert the linked list to an array, that takes O(n) time because we need to iterate. We need to follow the linked list from the beginning to the end, and we need additional space to store the numbers. And then we do this work, right? Not to mention removing the elements from an array usually O(n) time because array is a continuous space. You need to remove. It's just like you're going to the cinema, right? You're going to the cinema. I said this before, right? You're sitting here, Eric, Ryan, okay, and then there's some more seats here. And then, you made a mistake. You say, oh, this is your seat, but it's not. Then some people say here, oh, this is my seat. Okay, please move forward. And then you stand up, you go to this, and you ask Ryan to stand up, move towards. Okay, so look, these people needs to move one position to the right, so the efforts are O(n) time.
People got a mistake.
Yeah. Because you are in the wrong seat, right? Okay.
You actually look after tickets, not actually rely on children.
Good. Okay. That's good. Simple, right? How do we solve this problem? Simple, right? Look, we just first of all we have to set a dummy head, right? Dummy. What's dummy? Not used.
Like.
Dummy. It points to list. Yeah.
That's stupid. No,
it means that not used.
Something fake for practice. Or something.
Fake for practice. That's perfect. Yes, it's perfect. Suitable here. Right. So dummy. It means that I'm not going to return it. It's just for the convenience. I just put a placeholder here. It points to this, and I check the next one. If it's in the forbidden, right? By the way, I need to convert this to set for O1 lookup time, right? Because looking up an element in the array is ON. Yeah.
If they're sitting there, how do they know where everyone sits? Because if they're relying on everyone, they must know where they sit. How do they know where they sit? Because they're not. Because if there's someone made a mistake and set the person sitting at the second cell in the front instead, the person that's sitting on the third is apparently supposed to sit in the accident makes it in the second, even though they don't know where the actual one sat.
Okay, so of course we have assumptions, right? We have an assumption. We don't, don't worry about why it's like that. It's just this assumption. Okay. So here, coming back to this. So dummy, right? So we have dummy, and then next we check the next one if it's in the forbidden. If it's in the forbidden, then we remove this node, right? If it's not in the forbidden, then we just keep moving. Okay. So let's say here we have a point here, right? So the next pointer points to a number which needs to be taken out. So how do I remove this? I have a pointer here. How do I remove this? I just have to look. This is simple. My pointer, I'm here. I just know that the next pointer, my next position, needs to be taken out. So I just have to say, this pointer, this node, the next. Basically, I want to change this line, right? Change this arrow. The next. I want to point to here.
Yeah.
But what's this? This is the next. Okay, so this current. So basically, the key thing here is current dot next.
I think we done this problem before.
Yeah, equals current dot next.
Okay, that's good.
Dot next, right? Simple, right? So here, look. I want to remove this node. Come back. I want to remove this node. So I need to point this link to the next positions of the next. So current dot next equals current dot next dot next. Okay?
What if it's the last one?
If it's the last one, then dot next will be empty. It still works. Okay? But that's a very good corner case. Okay? I like you to think. Always challenge me for this. This is very good because this is how we improve.
Okay.
If you agree everything I told you, then your brain is not thinking. Okay? I like the challenge. So you need to challenge me. Yeah. And then I can always explain. Okay? Okay, so let's write the code. Okay, so you get that, right? Okay, let me find out which lesson we talk about. I think we have talked about it before, but this is...
Yeah, we have.
Then I need to show you the code and that's it. Okay, it's quite simple. Okay, and let me quickly write the code. Okay, so it should be quite simple. Define, give a name please. Ryan?
Mr.
Random project again?
Random project carrots.
Random project. Okay, what carrot? Okay, whatever. Okay. We'll give numbers and I'll give it a head.
Chesley.
Yeah.
Colin.
If not head. If the head is nothing, then we return head, right? Because if we given an empty thing, we just remove it. And then of course these numbers we need to convert it to a set. Wait. What? Okay. Random project. Carrots. Okay. Carrots. Okay.
What was in the brackets? Nums equals set what?
Nums.
No, that one.
Okay. Yeah. So this is just converted array to a set for faster lookup. Then okay, so we have this dummy, right? Dummy equals current equals it should be pointing to the head. Okay, so what does it mean? It means that I create a dummy node. And then dummy and current points to this dummy node. Yeah, this is basically to a dummy node which we have dummy and then the alias current. Okay, and then this node with the value of -1 or whatever. This value could be anything because it doesn't matter here. And then head. the second parameter is the next pointer, so it basically points to head. Okay, and then we can say while current.next, while we have the next element, and we check if current.next.value, if it's in these nums, if it's to remove, then we say current.next equals current.next, right? Otherwise, we just move it. Current.next. Current equals current.next. And then we just return dummy.next, right? Dummy.next. Okay? Yeah?
Yeah.
So we have to make sure this algorithm works in all cases, right? So the corner cases is that this is empty. The second is that if all the numbers are removed.
Okay.
So for example, like if we have a 9 and then 9 is removed, does it work? Yeah, it works, right? Because the next value is removed and .next. Then current.next will be at none and it returns none. Okay? And then if no elements are removed, then you simply fall into this if statement and you just walk into the next without modifying anything. So that still works. Okay? Yeah? So the time complexity O,
N.
the space complexity O, N, right? Because we're using a set. Okay?
Gang.
Yeah? Following the logic. Okay? That's it for today. Bye-bye.
Bye.
Bye.